Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have e to the power of x plus 3 is equal to e to the power of 3 plus e to the power of x. Now, if we have something in the form a to the power of m plus n, this can be written as a to the power of m times a to the power of n. So as you can see right here, we have e to the power of x plus 3. I'm actually going to rewrite this as e to the power of x times e to the power of 3. And now this is equal to e to the power of 3 plus e to the power of x. Now I'm actually going to subtract e to the power of x on both sides. So now we get e to the power of x times e to the power of 3 minus e to the power of x is equal to e to the power of 3. So now if I factor out e to the power of x, we get e to the power of x times e to the power of 3, because e to the power of x times e to the power of 3 divided by e to the power of x is simply just e to the power of 3, minus e to the power of x divided by e to the power of x is 1. This is equal to e to the power of 3. Now I'm going to divide by e to the power of 3 minus 1 on both sides. These two cancel out, and we get e to the power of x is equal to e to the power of 3 over e to the power of 3 minus 1. Now I'm actually going to take the ln of both sides, because the natural log, or ln, is the inverse or the opposite of e, meaning those two would cancel out. So if I take ln on both sides, get ln e to the power of x is equal to ln e to the power of 3 over e to the power of 3 minus 1. And if we take the ln of e, these two would actually cancel out, and we would simply just be left with our exponent, which in this case is x. So it would be, we would have x is equal to ln e to the power of 3 over e to the power of 3 minus 1. So this is our answer. Welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 5 to the power of x is equal to 7. Now what I'm first going to do is I'm going to take the log of both sides. So now we're going to have log 5 to the power of x is equal to log 7. So now an important property of logarithms is, let's say we have log a to the power of b The power property of logarithms states that we can actually move this exponent here, b, into the front of the log, meaning this would equal b log a. So right here we have log 5 to the power of x, and we can actually move our x here into the front of the logarithm. So now this would be equal to x times log 5. And this is equal to log 7. Now, I actually want to isolate x because that's the thing we want to find the value of. So I'm going to divide by log 5 on both sides to get rid of the log on this side and to move it to the right side. So now for our left-hand side, these two cancel out. So we would have x is equal to log 7 is equal to 0.845 approximately. And we're dividing this by log 5, which is approximately equal to 0.699. So now the answer for this, x would approximately equal 1.209. So this is our answer.